All right, let's take a look at our practice test. We're told to solve each inequality, write in interval notation, and then graph the interval. All right, for the first problem, we're looking at 2x squared minus 6x plus 2 is greater than negative 2. So the first thing I'm going to do is actually make the right-hand side of this inequality 0. So to do that, I'm just going to add 2 to both sides of the inequality, cancel this away and put 0 here. So we'll have 2x squared minus 6x, then plus 4, and this is greater than 0. Now you might notice that everything here in this inequality is divisible by 2. So I'm just going to make my life a little bit easier. And remember, you can always divide both sides of an inequality by a positive number, and you won't change the solution set. So I'm going to divide by 2 here, 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 and here. And so 2 divided by 2 is 1, so this is x squared. Then minus 6 divided by 2 is 3, so this is 3x. And then plus 4 divided by 2 is going to be 2. And this is greater than 0 over 2 is 0. Okay, so the idea now is basically I can replace this inequality symbol with equals, and I can solve the resulting equation. Now that's going to give me my critical values, and we'll talk more about that in a second. So let's just actually set this up. So we're going to go x squared minus 3x plus 2. Let's say this is equal to 0. Now how could I solve this? Well, I could use the quadratic formula, but I think it's quicker in this case to just factor. So let's see what we get here. So we'll say that we have x here and x here. We need two integers that have a sum of negative 3 and have a product of positive 2. So that's going to be negative 2 and negative 1. Now, if I solve this using the zero product property, you would basically set x minus 2 equal to 0, or you would set x minus 1 equal to 0. And over here, you just add 2 to both sides of the equation. So x is equal to 2. Over here, you add 1 to both sides of the equation. So you get x is equal to 1. Okay, so these are the critical values. Essentially, you're just using these values to split your number line up into these different regions. Before I go to the next sheet where we have our number line, I just want to factor this real quick so that we have it. So x minus 2, that quantity times the quantity. We're going to have x minus 1 and put this as greater than 0. Okay, so once you have your little number line set up, you really only need your critical values. So I found 1 and 2. Right, so you're going to put these on the number line, or you could use a table, whatever you want to do. So I'm going to put a 1 here and a 2 here, and then you can just get rid of this. You don't need it anymore. And I like to have this in factored form. It just makes the calculations a little bit quicker. Of course, you could just use a calculator, but it's really up to you. So what I want to do here is just set up these regions. So let's just call this region A, this B, and this C. And basically, these critical values are not included. Okay, so we want to think about those separately, and I'll talk about that towards the end. But basically, this is where x is strictly less than 1. This is where x is greater than 1 and less than 2. And here, this is where x is strictly greater than 2. Okay, so we would take a number inside of each region and test it in our inequality and see if it's true. So if it works, then every number in that region is going to work. If it doesn't work, then no number in that region is going to work. Okay, so what we would do here is start with region A. So x is strictly less than 1, so you could pick something like 0, and you could plug that in here and here. Now, you can go through and do the calculation, or you can just figure out, will this be greater than 0, meaning is it going to be positive? Well, you can just eyeball that and see that you would have negative 2 there times negative 1. Well, negative times negative is positive, so I know that this would be a positive result. In this case, it would be positive 2. So you can just put a t here for true, put a t there for true, or you could write true out, whatever you want to do, but all the numbers inside of this region A are going to work. So x could be anything less than 1. Those numbers would all satisfy the inequality. Now let's go to something in region B. So x is greater than 1 and less than 2. I would pick something like 1.5 or 3/2. So you're going to plug in, let's say 1.5 there, like this. And again, you don't have to actually do the calculation. You can just think about the sign. 1.5 minus 2 is going to be negative. Then 1.5 minus 1 is going to be positive. So negative times positive will give me negative, and a negative is not greater than 0. So this here would be false. And if this is confusing for you, you can just crank this out with your calculator. This would be 1.5 minus 2 is negative 0.5, and this would be 1.5 minus 1, which is positive 0.5. You multiply those together, and you get negative 0.25, right? So we know that's not greater than 0. Okay, for region C, where x is strictly greater than 2, let's just pick 3. So let's just pick 3. And you can see that 3 minus 2 would be 1. and then 3 minus 1 would be 2. So again, you only have to think about the result. Is it going to be positive or negative? So this is a positive times another positive, so it would work here. A positive would always be greater than 0, so this is true. Again, if you want to crank it out, 3 minus 2 again is 1, 3 minus 1 is 2, so 2 times 1 would give you 2. Now in terms of your critical values, you want to think about those at the end, and all you have to think about is the inequality symbol that you're working with. In this case, you have a strict inequality. So if you have a strict inequality, that means that these critical values are going to be excluded from the solution. And you can eyeball that and see that it's not going to work. If you plug in a 1 there, then you have 1 minus 1, which is 0. 0 times anything is always 0. 0 will not be greater than 0, so this is going to fail. For a similar reason, this one's going to fail. But if I change this to greater than or equal to, then they would both work, right? Because you would have 0 is equal to 0. So what you want to do in this particular case is exclude them. So you would want to list your solution by saying that x is strictly less than 1 or x is strictly greater than 2. And then in interval notation, we could say that we have from negative infinity up to and not including 1. And then we'll put the union with, we'll have anything greater than 2. Right? So basically a parenthesis next to 2. And again, this is going out to positive infinity. Now let me show this on the graph. So coming to our number line here, let's just put a 1 here and then a 2 here. And then for x is less than 1, again, at 1, I would put a parenthesis here. Some books will put an open circle to show that it's not included. And then I'm just going to shade everything to the left. And then for x is greater than 2, again, I'm going to put a parenthesis here. And then I'm just going to shade everything to the right. So again, your book might use an open circle just to show that it's not included. So that's up to you what you want to do. But this would be my solution graphically. Then you have x is less than 1 or x is greater than 2. And then, of course, an interval notation. All right, let's take a look at problem number 2 now. So we have 6x squared minus 10x plus 2 is less than 6. Again, what I'm going to do is make this right-hand side 0. So we'll subtract 6 away from each side of the inequality. Cancel this away and put 0. We'll have 6x squared minus 10x. 2 minus 6 is going to be negative 4. So let's put minus 4. And this is less than 0. All right, so from here, you'll notice that, again, you could divide everything by 2. And dividing everything in an inequality by the same positive number does not change the solution set. So I'm going to divide by 2, divide by 2, divide by 2, divide by 2. And I'm going to have 3x squared minus 5x minus 2. And this is strictly less than 0. Okay, so I'm going to replace this inequality symbol with an equal symbol. And so I'll basically have 3x squared minus 5x minus 2 is equal to 0. I'm going to leave a little space because I'm going to put the factored form up there in a second. So let's just try to factor this real quick. So we would have 3x and x, because again, 3 is a prime number, so that's a given. Then for 2, forget about the fact that it's negative. It's 2 times 1 only. So what I want to put a 2 here and a 1 here. Well, 3 times 2 would give me 6, and then 6 minus 1 would give me 5. So I want this to be negative, and I want this to be positive. My outer here would be negative 6x. My inner here would be positive x. Negative 6x plus x would give me negative 5x. So this is what I'm looking for. So let's put this up here so we have it. So 3x plus 1, this quantity times the quantity x minus 2. And then this is going to be strictly less than 0. Okay, so we'll have that for later on. So for right now, let's just go through and solve this using our zero product property. So we'll have 3x plus 1 is equal to 0. Then or, you're going to have x minus 2 is equal to 0. So what we'll do is subtract 1 away from each side of the equation here. Cancel this. We'll have 3x is equal to negative 1. Divide both sides of the equation by 3. Let's cancel this away. And basically, you're going to have x is equal to negative 1/3. Over here, you just add 2 to both sides of the equation. So basically, let me just show this. We'll have or x is equal to 2. Okay, so coming to where I have my number line set up, let's just do the same thing. So I'll just call this region A, region B, and region C. And the numbers we're working with, the critical values, will have negative 1/3, and then we're going to have positive 2. Let me make this 3 a little bit better. Once you write this in, you can just get rid of this. You don't really need this anymore. So let's just move this up a little bit. And basically, I just want to specifically note that here we have x is strictly less than negative 1/3. Here we have x is greater than negative 1/3, and it's less than 2. And then here, x is greater than 2. Then recall that because we have a strict inequality here, these endpoints or critical values are not going to be included in the solution. Okay, so let's just test things and see if they work. Again, you can just think about the sign. Is it going to be negative? If it's going to be negative, that means it's less than 0. So we would basically accept it as a solution. If it ends up being positive, then we're going to reject it, right? We're looking for this to be less than 0. So what is less than negative 1/3 that we can use? We could use -1. So if you plugged in a -1 there, I know this would be negative. If I plugged in a -1 there, 3 times -1 is -3. -3 plus 1 is going to be -2, so this is negative as well. Well, negative times negative would give me a positive, and a positive is not less than 0. So this one is not going to work. I'm going to put an F there for false. And let's move on to the next one. And again, if you want to, you can always just go through and plug in and figure out what the value is, and you can compare it that way. It's just up to you. So for the next one, I need something that's greater than -1/3 and less than 2. Let's just use +1. So plug in a 1 there and a 1 there. 1 minus 2 is -1. So this is going to be negative. And then here, 3 times 1 is 3. And then 3 plus 1 would be 4. So this would be positive. Positive times negative would give you a negative. So yes, this would be less than 0. So we want to say that this would be true here. And then for the last one, we have x is greater than 2. So you could pick something like 3. So you'd plug in a 3 there and a 3 there. 3 minus 2 would give you +1. So let's put a plus sign here. And then basically 3 times 3 would give you 9. 9 plus 1 would give you 10. So let's put a plus sign there. Positive times positive is positive. So a positive will never be less than 0. So this one would be false here. So we can say that our solution here is basically going to be that x is greater than -1/3 and it's less than 2. Remember, we're using strict inequalities here because the inequality we got originally was a strict inequality. So the -1/3 and the 2, those are going to be excluded. Now in interval notation, basically I'm just going to show this like this. So -1/3 next to a parenthesis, then comma, you're going to have 2 next to another parenthesis like this. And then graphically, let's put -1/3 here. Let's put 2 here. So this is where you can put a parenthesis here and a parenthesis here. Or again, you can put an open circle, and then I'm just going to shade everything in between. So here, x can be any number that is greater than -1/3 and less than 2. All right, let's take a look at problem number 3 now. So we have 6x squared is greater than or equal to 5x squared plus 99 plus 2x. All right, so let's clean this up a little bit. What I'm going to do is subtract 6x squared away from each side of the inequality. Let's cancel this away and put 0 over here. So we'll have 0 is greater than or equal to 5x squared minus 6x squared is going to give me -x squared. Then you have plus, we're going to write the 2x next, and then plus 99. All right, so I always like my variables to be on the left. So what I'm going to do is actually write this as -x squared plus 2x plus 99. And note that this symbol is pointing in this direction. So I'm going to keep it that way. I'm basically going to say this is less than or equal to 0. So if you read it from this way, you see that 0 is still greater than or equal to this guy right here. Okay, so it's important to check that if you're rewriting things. Now, one thing I would do here, if I'm going to factor this, I don't like a negative leading coefficient. You could pull out a -1, but what I like to do is actually divide everything by -1. But remember, if you're working with an inequality and you multiply or divide by a negative number, you have to flip the direction of the inequality symbol. So I'm going to divide this by -1, this by -1, this by -1. I'm going to flip this, and then I'm going to divide this by -1. So this gives me x squared, then minus 2x, then minus 99. This will now be greater than or equal to, and this will still be 0. Now I'm going to replace this inequality symbol with equals and solve the resulting equation. And let me just put a little space here because, again, I want to write this in factored form just to make things a little bit easier on myself. So give me two integers whose sum is -2 and whose product is -99. Well, let me put my x here and my x here. Well, 99 is basically 9 times 11 or 3 squared times 11. So let's think about 9 and 11. Can we make that work? Well, if I did a -11 and a +9, yeah, that would work. So if I did a -11 and a +9. Let's put this up here. So x minus 11, this quantity times the quantity x plus 9. And this will be greater than or equal to 0. So we're going to need that for later on. Okay, so I'm just going to solve this using my zero product property. So x minus 11 equals 0, or x plus 9 is equal to 0. From here, let's add 11 to both sides of the equation. Cancel this away. We'll get x is equal to 11. Then, or, over here, let's subtract 9 away from each side of the equation. Cancel that away. We'll say x is equal to negative 9. So coming to my number line, I'm going to put negative 9 here and positive 11 here. So again, this will be region A. Let's call this B. Let's call this C. Here we'll have x strictly less than negative 9. Here we'll have x is greater than negative 9 and less than this positive 11. And here x is strictly greater than 11. Now you'll notice that we have a non-strict inequality here. We have the greater than or equal to. So that just tells us that negative 9 will work as a solution and 11 will work as a solution. Why? Because again, if you plugged in a negative 9 here, negative 9 plus 9 is 0. 0 times anything is 0. So you will get 0 is, again, equal to 0. So it satisfies this part right here. Okay. The same thing would happen with 11. So these guys would now be solutions, but we'll notate that later on. For right now, we're not even worried about it. We would first test something in this region A. So let's maybe take a look at something like negative 10. If you plugged in a negative 10 there and a negative 10 there, so that gives me a negative, right? Negative 10 minus 11 would give me negative 21. Then here, negative 10 plus 9 is going to be negative 1. So again, this gives me another negative. Negative times negative gives me positive, right? And a positive is going to be greater than 0. So we know that inside of this region A, it's going to be true. All right, let's look at the next region, which is region B. You could pick 0 there. That's going to be really easy to work with. So plug in a 0 there and there. And you see that 0 minus 11 would be negative 11. So this is negative. 0 plus 9 would be positive 9. So this is positive. Negative times positive is negative. And a negative will not be equal to 0 and it will not be greater than 0. So this right here is going to be false. Then for the other guy, let's look at x is greater than 11. Maybe we'll pick something like 15. I think that's pretty easy to work with. So let's go 15 here and let's go 15 here. And you can see that 15 minus 11 would be 4. So this is a plus. And 15 plus 9 is going to be 24. So this is a plus here. Positive times positive is positive. And any positive is always going to be greater than 0. So this is going to be true. Let's get rid of this and let's write our solution now. And again, these critical values here, negative 9 and 11 will be included. So x can be less than or equal to negative 9, or x can be greater than or equal to 11. And then in interval notation, so we'll have from negative infinity up to and including negative 9. So you want to use that bracket there. And then the union with here, we want to use a bracket next to 11. And then comma, we're going to go out to positive infinity. Okay, so let's put negative 9 here, positive 11 here. And what you'd want to do is put a bracket here, or again, some books in this case will use a closed circle, or you could say a filled in circle to show that negative 9 is included. And then you want to shade everything to the left. Here at 11, I'm just going to put a bracket there to show 11 is included, and I'm going to shade everything to the right. All right, let's take a look at problem number 4 now. So we have 6x squared plus 17x minus 8 is less than or equal to 9x. So the idea here is I'm just going to subtract 9x away from each side of the inequality. I'm going to make this right-hand side 0. And so what I'll have is 6x squared. 17x minus 9x would be 8x. So plus 8x minus 8, and this is less than or equal to 0. Again, if you notice, I could make this simpler by dividing everything by 2. So I'm just going to divide everything here by 2. And so this is going to give me 3x squared plus 4x minus 4 is less than or equal to 0. So from here, I'm just going to leave a space, and I'm going to replace this with an equation. So 3x squared plus 4x minus 4 is equal to 0. And I'm going to put my factored form here, and I'm also going to put it up here. But let's just do it down here first. So 3 is a prime number, so I can just right away put 3x here and x here. Let's think about 4. You've got 1 and 4, or you've got 2 and 2. So if I put a 4 here and a 1 here, that is going to be too big, right? 3 times 4 is 12. 12 minus 1 would be 11. If I switch that around and put a 4 here and a 1 here, now you've got 3 and 4. 4 minus 3 would give you 1. So this is not going to work. So it's going to have to be 2 and 2. So basically, you're going to have 6 minus 2, which would give me 4. So let's put a plus here and a minus here. So this would give me 6x. This would give me negative 2x. 6x minus 2x would give me positive 4x. So this is exactly what I want. All right, let me copy this up here, actually. So we'll have 3x and then minus 2, this quantity, times the quantity x plus 2, like this. And we'll say this is less than or equal to 0. All right, so for this one right here, let's set 3x minus 2 equal to 0, then or x plus 2 equals 0. We already know this one. We'll just say x is equal to negative 2. Again, you could just subtract 2 away from each side of the equation. That's real simple. Then over here, let's add 2 to both sides of the equation. Cancel that away. We'll say 3x is equal to 2. Divide both sides of the equation by 3. This cancels. And you get x is equal to 2/3. So you have x equals 2/3 or x equals negative 2. So let's go to the number line. Okay, so let's put negative 2 here and then positive 2/3 here. Again, I'm going to call this region A, region B, and region C. So this is x is strictly less than negative 2. This is x is greater than negative 2 and less than 2/3. And then this right here is going to be x is strictly greater than 2/3. Okay, you can get rid of this at this point. I know that negative 2 and then also 2/3, those are going to work as solutions here. So I need to make sure I remember to include them. And I'm just going to test values here. So something less than negative 2, let's just pick negative 3. So let's pick negative 3, and that's going to get plugged in each case. Well, 3 times negative 3 is going to be negative 9, and then negative 9 minus 2 would be negative 11. So I know this is negative. And then here, negative 3 plus 2 would be negative 1, so I know this is negative. Negative times negative is positive. So a positive is not less than 0. So we know that this right here wouldn't work, so this is false. So going to the next one, we would have something between negative 2 and 2/3. You could pick 0. I think that's really easy to work with. So let's plug that in. You'd have negative 2, and then basically times positive 2. So that's obviously going to be negative 4, because this is a negative and this is a positive. So a negative is always going to be less than 0. So this is true. Okay, so looking at the next guy here, we have something that's greater than 2/3. So let's just pick 1. So let's plug in a 1 there and there. So 3 times 1 is 3, and 3 minus 2 is going to be 1. Here, 1 plus 2 is 3. So we know that this is positive and this is positive. Positive times positive is positive, and a positive is never going to be less than 0. So this is going to be false. Okay, so let's just write our solution here. And again, we had a non-strict inequality. So negative 2 and then also 2/3, those need to be included. So we'll say that x is greater than or equal to negative 2, and it's less than or equal to 2/3. In interval notation, again, you just want to make sure you use your brackets. So you have a bracket next to negative 2, and then a bracket next to 2/3. So let's put a negative 2 there. Let's put a 2/3 there. Let's put our bracket in here to show that it's included. Again, you can use a filled in circle. Let's put a bracket here to show that's included. And let's just shade everything in between to show that, again, from negative 2 and including negative 2, going up to 2/3 and including 2/3, those values work as a solution. All right, let's take a look at problem number 5 now. So we have 6x squared minus 8x plus 1, and this is greater than negative x. So I'm just going to add x to both sides of the inequality. Cancel this away and say this is 0. We'll have 6x squared. Negative 8x plus x would be negative 7x. Then plus 1, and this is greater than 0. And again, I'm just going to put 6x squared minus 7x plus 1. I'll say this is equal to 0, just to find the critical values. Let's factor this guy right here. So for 6, it's either 6 times 1 or 2 times 3. I've already worked this problem, so I know it's 6 times 1, so I'm not going to waste your time. I'm just going to say this is 6x and x here. And then 1 can only be 1 times 1, right? So I can put a 1 here and a 1 here. I basically just need to work out the fact that this would be negative and this would be negative, right? So basically you'd have negative 6x here. So negative 6x here, and then negative x here. Negative 6x plus negative x would give you negative 7x. Okay, so let me write this above here and just say this is 6x minus 1, this quantity, times the quantity x minus 1 here. And then I'll put this as strictly greater than 0. So to solve this down here, we'll say 6x minus 1 is equal to 0. Or we'll say x minus 1 is equal to 0. For this one, let's add 1 to both sides of the equation. Cancel that. We'll have 6x is equal to 1. Divide both sides of the equation by 6. Let's cancel this away. We'll say x is equal to 1 over 6. Over here, let's add 1 to both sides of the equation. Cancel that away. We'll say or x is equal to 1. So let's put 1 over 6 here. Let's put 1 here. And again, I'm just going to write this as region A. This is where x is strictly less than 1 over 6. Let's say this is region B, and this will be where x is greater than 1 over 6 and less than positive 1. This will be region C. We'll say x is strictly greater than 1. Okay, so once again, we're just going to plug in here and see if we get something that's greater than 0. So you can plug it in and get the value, or you can plug in and just figure out the sign. It's up to you. So for this one, let's just start off by picking 0. Plug in a 0 there and there. So 6 times 0 is 0. 0 minus 1 is negative 1. So this is negative. Here, 0 minus 1 is negative 1. So this is negative. Negative times negative will give me a positive. So a positive is always greater than 0. So I'll go ahead and say that this is true. Then coming over here, I need to pick something that is between 1 over 6 and 1. So this one is a little bit tricky. Let's maybe pick 1/2. So let's plug in a half there and a half there. This one's easier to do. A half minus 1 would be negative a half. So let's put minus there. We know that's going to be negative. Here, 6 times a half would be 3. 3 minus 1 would be 2, so this is positive, right? So positive times negative is going to give me a negative, and a negative is never going to be greater than 0, so this is going to be false. For C, let's just pick positive 2. I think that's pretty easy to work with. So 6 times 2 is 12. 12 minus 1 is 11, so let's put a positive sign there. Then 2 minus 1 is 1, so that's going to be positive as well. Positive times positive is going to be positive, so this is true. Now remember, you have a strict inequality here, so these critical values are going to be excluded from your solution. And to write it, I'm just going to say that x can be strictly less than 1/6, or we could say that x is strictly greater than 1. In interval notation, we'll say from negative infinity up to and excluding this 1 over 6. And then the union with will have excluding 1 going out to positive infinity. So let's put 1 over 6 here and 1 here. And again, these are going to be excluded. So I'm going to use a parenthesis in each case, or you can use an open circle, whatever you want to do. I'm just going to put a parenthesis here, shade to the left, and then I'm going to put a parenthesis here and then shade to the right. All right, let's take a look at problem number 6 now. So we have 5x squared plus 6x is less than 11. And again, I'm just going to subtract 11 away from each side of the inequality. Cancel that away and put 0. So let's write this as 5x squared. Then we have plus 6x minus 11, and this is strictly less than 0. Let me make this 2 a little bit better. Okay, so down here, I'll just write 5x squared plus 6x minus 11 is equal to 0. Again, I'm just going to solve this using factoring. So we'll put a 5x here and an x here because 5 is a prime number. For 11, that's a prime number as well. Forget about the fact that it's negative. So it can only come from 1 times 11. So if you put an 11 here, that's obviously going to be too big. So it would have to be an 11 here and a 1 here. And so what you would want is for this guy to be positive and this guy to be negative. So basically that you would get this negative 5x here and this positive 11x here. Negative 5x plus 11x would give you positive 6x. Okay, so this is my correct factorization. Let me just write it up here. So 5x plus 11, this quantity, times the quantity x minus 1, and this would be strictly less than 0. So here, let's go 5x plus 11 is equal to 0, then or x minus 1 is equal to 0. Let's subtract 11 away from each side of the equation. Cancel that away and say 5x is equal to negative 11. Let's divide both sides of the equation by 5. Cancel this away and say x is equal to negative 11 fifths. Over here, let's just add 1 to both sides of the equation. Cancel that away, and I'll say or x is equal to 1. Okay, so coming to the number line, let's put negative 11 fifths here. Let's put positive 1 here. You can get rid of this information. You don't need it. Let's say this is region A, this is region B, this is region C. So for region A, it's anything where x is going to be strictly less than negative 11 fifths. Here, x is greater than negative 11 fifths, and it's less than positive 1. Here, x is strictly greater than 1. Okay, so just using a test point in each case, for something that's less than negative 11 fifths, let's just use negative 3. So let's use negative 3. And let's see what that would give us. So 5 times negative 3 would be negative 15. Then negative 15 plus 11 would be negative 4. So I know this would be negative. Then here, negative 3 minus 1 would be negative 4. So I know this would be negative. A negative times a negative would give me a positive, and a positive is never going to be less than 0. So this right here is going to be false. Let me actually slide this down just a little bit. So from here, what I want to do is test something in region B. So I think 0 would work pretty well. Plug in a 0 there, you would get 11. plug in a 0 there, you would get -1. So you have a positive times a negative, which would give you a negative, and a negative is always going to be less than 0. So this is true. Let's get rid of this and this. And then basically for the last one, where x is greater than 1, let's just pick 2. So you plug in a 2 there, you're going to get 1, so this is positive. Plug in a 2 there, 5 times 2 is 10, 10 plus 11 is 21. That's going to be positive as well. Positive times positive is positive, and that's never going to be less than 0. So let's go ahead and say this is false. Now remember, you have a strict inequality, so these critical values are excluded from the solution. So we'll just say that x is going to be greater than -11/5. We'll say and it's less than 1. So in interval notation, we'll say -11/5. Again, this is excluded. That's why we have the parenthesis. And then comma, you'll put a 1. And again, this is excluded. That's why you have the parenthesis. So graphically, let's say this is -11/5. Let's say this is 1. And again, I'm going to use a parenthesis with each here to show that they're not included. You can always use the open circle. And then I'm going to shade everything in between. So x can be anything greater than -11/5 going up to and excluding +1. All right, let's take a look at problem number 7 now. So we're going to have x squared minus 17x plus 5 is greater than or equal to -11x. So let's add 11x to both sides of the inequality. And let's cancel this away and put 0. So over here, let's say that we have x squared. We have -17x plus 11x. That's going to give me -6x. Then we're going to have plus 5, and this is greater than or equal to 0. So let's write this down here. X squared minus 6x plus 5 equals 0. Really, really easy to factor this. We'll put an x here and an x here. We need two integers that give me a sum of -6 and have a product of +5. Well, that's going to be -5 and -1. So up here, let's go x minus 5, this quantity, times the quantity x minus 1, and this will be greater than or equal to 0. Okay, so let's use our zero product property to get our critical values. We'll say x minus 5 is equal to 0, or x minus 1 is equal to 0. From here, let's add 5 to both sides of the equation. Cancel this. We'll get x is equal to 5. Then or, let's add 1 to both sides of the equation. Cancel this. You'll get x is equal to 1. All right, let's put a 1 here and a 5 here. Let's get rid of this. Let me slide this down just a little bit so it all fits in here. Let's put this as region A, B, and C. We'll have x is less than 1. Here we'll have x is greater than 1 and less than 5. And here we'll have x is greater than 5. So for this one, if I pick something like, let's say, 0, and I plug that in here and here, well, this would be -5 and this would be -1. So negative times negative would give me a positive, and a positive is always greater than 0, so this is going to be true. For the next one, let's say we pick something like 2. So we plug in a 2 there and a 2 there. Well, 2 minus 5 is -3, so this is negative. And then 2 minus 1 is going to be +1, so this is positive. Negative times positive is negative, and a negative is never going to be greater than 0. So this is false. Then over here, we have x is greater than 5. Let's just pick 6. Plug in a 6 there and a 6 there. 6 minus 5 is 1, so this is positive. 6 minus 1 is going to be 5, so this is positive. Positive times positive is positive, and that's always going to be greater than 0, so this is true. So for the solution here, remember it's a non-strict inequality, so the critical values are included. You would have that x is less than or equal to 1, then or x is greater than or equal to 5. So what we would say here is that we have from -infinity up to and including +1, put a bracket there, and the union with 5 is included, so put a bracket there. So from 5 going out to +infinity. All right, so let's put a 1 there and a 5 there. And again, I'm just going to use a bracket with each. So I'll use a bracket here to show 1 is included. And then I'm just going to shade everything to the left. Here I'll use a bracket to show 5 is included, and I'll shade everything to the right. All right, let's take a look at problem number 8 now. So we have -6x squared minus x is less than or equal to 12 minus 7x squared. All right, so let's add 7x squared to both sides of the inequality. Let's get rid of this. And then let's subtract 12 away from each side of the inequality. Let's cancel this. Let's put this as 0. -6x squared plus 7x squared is x squared. Then you have minus x and then minus 12, and this is less than or equal to 0. So let's write this as x squared minus x minus 12 is equal to 0. And so from here, I'm going to factor this as x and then x. We know two integers that sum to -1 and have a product of -12 would be -4 and +3. So actually, let me write this up here. So x minus 4. that quantity times the quantity x plus 3. Let's put this as less than or equal to 0. Let's solve this. So x minus 4 would be equal to 0. Obviously, x is equal to 4. Just add 4 to both sides of the equation. Then or, over here, let's say x plus 3 is equal to 0. Here, we would subtract 3 away from each side of the equation. We would get x is equal to negative 3. All right, let's put negative 3 here. And let's put positive 4 here. Let's set this up as region A, and let's call this B, and then C. So this will be anything where x is less than negative 3. This will be x is greater than negative 3 and less than positive 4. And this will be x is greater than 4. And then for something that's less than negative 3, let's just pick negative 4. So we'll plug a negative 4 in there and there. So negative 4 minus 4 would be negative 8. So this is negative. Negative 4 plus 3 is going to be negative 1. So this is negative. Negative times negative is positive, and a positive is never going to be less than 0. So this is going to be false. Now let's move on to the next interval, which includes 0. So I'm just going to use that. I think that's probably the easiest number to work with. So this would be negative 4. This would be positive 3. You have a negative times a positive, which would give you a negative, and a negative is always going to be less than 0. So this is going to be true. Okay, so let's move on to this one over here where x is greater than 4. Let's maybe pick 5. I think that's easy to work with. 5 minus 4 would be 1, so this is positive. Then 5 plus 3 would be 8, so this is positive. Positive times positive is positive, and a positive is never less than 0, so this is false. Okay, so remember, this is a non-strict inequality, so we are going to include these critical values, negative 3 and 4, in our solution. So we'll say that x is greater than or equal to negative 3, and it's less than or equal to positive 4. In interval notation, let's put a bracket, and then negative 3, a comma, we'll put 4, and then a bracket. And then graphically, I'll put negative 3 here, and then 4 here. And again, we're going to use a bracket here, and a bracket here. And then I'm just going to shade everything in between. So it could be negative 3, and then any number going up to and including positive 4. All right, let's take a look at problem number 9 now. We have 5x squared minus 20x minus 32. This is less than or equal to negative 8x. Okay, just going to add 8x to both sides of the inequality, just like we've been doing. Cancel this and put 0. Let's take a look at 5x squared. Negative 20x plus 8x would be negative 12x. Then you have minus 32, and this is less than or equal to, we would put 0 there. And again, I'm just going to first replace this inequality symbol with equals. So we'll have 5x squared minus 12x minus 32 is equal to 0. And so to factor this, let's put 5x here, and let's put x here. Let's put this over here as equals to 0. And 32 has a few possibilities. So let's really think about this. So you have 1 and 32. Would that ever work? Remember, because this is a negative here, you're going to subtract and try to get to 12. Forget about the fact that it's negative. If I put a 32 here, it's way too big. If I put a 32 here and a 1 here, that's still going to be too big. So 1 and 32, that's going to be out. Forget about that. The next one would be 2 and 16. So would 2 and 16 work? Well, if I put a 16 here, that's too big, right? 5 times 16 is 80. That's just not going to work. If I put the 16 here and the 2 here, that's going to be 16 minus 10, which is 6. So that doesn't work either. So next you would have 4 and 8. And let's see, if I put the 8 here, that's 40. That's too big. If I put the 8 here and the 4 here, well, now I have 20 minus 8, which is 12. That's what I want, right? I just have to work out the signs. So in this particular case, I want this one to be negative and this one to be positive. That way I can get a negative 20x and then a positive 8x. Negative 20x plus 8x would give you negative 12x. So now let's say that 5x plus 8 is equal to 0, or x minus 4 is equal to 0. Let's subtract 8 away from each side of the equation. And let's say 5x is equal to negative 8. Then we'll divide both sides of the equation by 5. Cancel that. We'll say x is equal to negative 8 fifths. Then or, we'll say here we're going to add 4 to both sides of the equation. We'll say x is equal to 4. Let's put this as negative 8 fifths. Let's put this as 4. Let's go back and grab the factored form of that inequality. So coming back up here, let's just write this as less than or equal to like this. We'll grab it and let's see what we have. So I'm going to say this is region A, B, and then C. So this is x is strictly less than negative 8 fifths. So this is x is greater than negative 8 fifths. And it's going to be less than positive 4. This is x is greater than 4. Okay, so coming through here, if we think about something less than negative 8 fifths, well, you could use something like negative 2. So if I plugged in a negative 2 there and there, what would you get? Well, 5 times negative 2 is negative 10, and then negative 10 plus 8 is going to be negative 2, so this is negative. Here, negative 2 minus 4 is negative 6, so this is negative. Negative times negative is positive, and a positive is not less than 0, so this is going to be false. Then thinking about this one right here, let's just use 0. Again, that's probably the easiest number to work with. So let's plug in a 0 there and there. Here you would have 8, and here you would have negative 4. So this is positive and this is negative, and that's going to give me a negative, which is always less than 0, so this is true. And then thinking about in interval C, something that's greater than 4, so put a 5 there and then also there. 5 times 5 is 25, then plus 8, that's going to be 33, so this is positive. Here 5 minus 4 is 1, so that's positive. Positive times positive is positive, and so a positive is never going to be less than 0, so this is false. So this is a non-strict inequality, so the critical values will be part of our solution set. So let's go ahead and say that we have x is greater than or equal to negative 8/5, and it's less than or equal to positive 4. In interval notation, again, you put brackets here, so you have negative 8/5 there, comma, and then you can have 4 there, and just use a bracket with each because they're both going to be included. And then coming to the number line, you have negative 8/5 here, you have 4 there, and again, I just want to use a bracket here and a bracket here to show that it's included, and I'm going to shade everything in between. So x can be negative 8/5, and then anything going up to and including positive 4. All right, let's take a look at problem number 10. So we have x squared minus 5x is greater than or equal to. We have 143 minus 3x. So let's add 3x to both sides of the inequality. Cancel this away. Let's subtract 143 away from each side of the inequality. Cancel this away. Let's put 0 over here. So you have x squared. Then you have negative 5x plus 3x, which is negative 2x. Then minus 143. And this is greater than or equal to 0. So let's just leave a space and say x squared minus 2x minus 143 is equal to 0. And I'm just going to factor this and say this is x here and x here. For two integers that sum to negative 2 and give me a product of negative 143, when you think about 143, it's 13 times 11. So if you did a negative 13 and a positive 11, that would work, right? 11 minus 13 is negative 2. And 11 times negative 13 is negative 143. So let's write this up here. So x plus 11, this quantity times the quantity x minus 13, like this. And this is greater than or equal to 0. So using my zero product property, you have x plus 11 equals 0, or x minus 13 equals 0. Here we'll just say x is equal to negative 11. Again, just subtract 11 away from each side of the equation. Then or over here, we would add 13 to both sides of the equation. So x is equal to 13. All right, so here, let's put this as negative 11. Let's put this as positive 13. Let's get rid of this. Again, this will be region A. This will be region B. This will be region C. And essentially what I want to do here is just say that this is x is strictly less than negative 11. Here, x is greater than negative 11 and less than positive 13. And then here, x is greater than 13. Let me make this 3 a little bit better in each case. So a little bit cleaner. Okay. So let's pick something from region A. You can just pick something like maybe negative 12. So let's do negative 12 here and negative 12 here. And make this a little bit better. So negative 12 plus 11 is going to be negative 1. So I know this is negative. Negative 12 minus 13 is negative 25. So this is negative. Negative times negative is positive, and positive is always greater than 0. So this is true. Let's get rid of this, and let's go to the next region, which includes 0. So let's use that there. And there. Here you would have 11, which is positive, times negative 13, which is negative. Positive times negative is negative, and a negative is never greater than 0. So this one is false. Let me use different colors for this so it shows up. And let me come over here and actually change this to orange as well. Get rid of this and this and this. And so something that's going to be greater than 13, let's just pick 14. And let's plug that in here, and let's plug that in here. So 14 plus 11 is going to be 25, so that's positive. 14 minus 13 is going to be 1, so that's positive. Positive times positive is going to give you positive, and that's always greater than 0. So let me do this in orange. This would be true. And remember, this is a non-strict inequality, so these critical values are going to be included. Let's write our solution as x is less than or equal to negative 11. Then or, we're going to have x is greater than or equal to positive 13. In interval notation, let's say from negative infinity, going up to and including negative 11. So make sure you use a bracket there. And then the union with, you'll have from 13, and again, including 13, so that's why we use the bracket, going out to positive infinity. Okay, so graphically, let's put negative 11 there and positive 13 there. And again, these are each included. So let me put a bracket here, shade everything to the left. Let me put a bracket here and shade everything to the right.